In this video, I am going to discuss about the electric potential energy of the system of charges here. So the electric potential energy of a system of charges is the work that has been done in bringing the charges from infinity to near each other to form the system. Suppose AB is a system of two charges which is formed with the help of plus Q1 and plus Q2. And our aim is to find the electric potential energy of this system of charge Q1 and Q2 which is placed at A and B at distance r effort in air or vacuum. So for this purpose, first we will take the charge Q1 and we will calculate the work done in taking the charge Q1 from infinity to the point A. And when we will take the charge Q1 from infinity to the point A, then work done will be 0. Why? Because at that time no any other charge was present here. So in the absence of any other charge, the work done in taking the charge Q1 from infinity to the point A will be 0. Again, after taking the charge Q1 from infinity to the point A, now we calculate the work done in taking the charge Q2 from infinity to the point B. So, for finding the amount of work done in bringing the charge Q2 from infinity to the point B, first we calculate the potential energy. First we calculate the electric potential due to this charge plus Q1 at point B, means at distance r from it. Why? Because this charge Q1 is already present here. So electric potential at B due to charge Q1 at A. It means electric potential due to this charge plus Q1 at A at distance r from it, means at point B, is given by V is equal to 1 upon 4 pi epsilon naught Q1 by R. Now, this charge Q2 is taken from infinity to the point B. It means it is coming from V is equal to 0. It means at infinity the electric potential was 0, and when it will comes at the point B, then their electric potential was 1 upon 4 pi epsilon naught Q1 by R. So how can we find the work done in taking the charge Q2 from infinity to the point B? So the work done in taking the charge Q2 plus Q2 from infinity to the point B. By definition of the electric potential, we know V is equal to W by Q, where V is potential difference, W is the work done, and Q is charge. What charge is taking? Q2. And the potential difference between infinity and the point B is how much here? V. Or simply you can say the potential at B is how much here? V. So work done in taking the charge Q2 from infinity to the point B is W is equal to Q2 into V. It means Q2 into, at place of V, write down 1 upon 4 pi epsilon naught Q1 by R. Actually in this formula, V is potential difference, and potential difference means potential at final state minus potential at initial state. So your final state is B, initial state is infinity. So at final state potential is V and initial state potential is 0. So potential difference is equal to V here. So work done is equal to Q2 into 1 upon 4 pi epsilon naught Q1 by R. or you can say here W is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R. Now, this work be stored in the system in the form of electric potential energy. So, this work is the electric potential energy of the system of the charges, which is denoted by U. So, also you can write U is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R. So, this is the expression for electric potential energy for a system of two charges Q1 and Q2, which is separated by a distance R. So, by using this formula, we can find the electric potential energy of a pair of any two charges. Now, the some important points regarding to this electric potential energy. So, you know the formula for the electric potential energy of the system of two charges 1 upon 4 pi epsilon naught Q1 Q2 upon R. So, first important point is what here? In this formula, U is equal to 1 upon 4 pi epsilon naught Q1 Q2 by R. This formula we apply for the pair of the charges. And in this formula, Q1 and Q2 will always consider with sign. With sign means what is the charge Q1 and Q2 plus or minus. So that will be also considered here. Suppose Q1 is positive charge, Q2 is positive, so you will take both Q1 Q2 positive. If Q1 is negative, Q2 is negative, so here you write minus Q1 minus Q2. And if Q1 is positive and Q2 is negative, so that Q1 and Q2 will also consider with the proper sign. So first thing, electric potential energy, this formula is applicable for the pair of charges, and Q1 and Q2 will always consider with the proper sign. Second point, for like charges means either both Q1 and Q2 is positive or both Q1 and Q2 is negative. It means for like charges, the product Q1 Q2, it means the product Q1 Q2 in this formula be always greater than 0. And when Q1 Q2 be greater than 0, it means U will comes always positive. And for unlike charges means here either Q1 is positive, Q2 is negative, or Q1 is negative, Q2 is positive. So for unlike charges, the product Q1 and Q2 will always comes less than 0. It means U is negative. Third point, positive value of potential energy. Positive value of potential energy means for like charges, it shows net repulsion, while negative value of potential energy means for unlike charges, it shows net attraction. So be careful about this one. If potential energy is coming positive, it means overall it shows the net repulsion, indicates net repulsion, and while if potential energy is coming negative, then it shows the net attraction. And fourth point, which is also very important, since electric potential energy be always calculated for a pair of charge, and suppose a system is considered n charges. If a system consider or a system is formed, if a system is formed with n charges, then the number of pair of charges is equal to n into n minus 1 by 2. It means if a system contains n charges, then first we will find out how many pair will form. And how can we find the number of pairs? By using this formula, n into n minus 1 by 2, where n is the number of charges included in that system. For example, Here suppose three charges Q1 minus Q2 and Q3 be placed at the vertices of a triangle, and suppose R1, R2 and R3 be the distance between Q1 minus Q2, Q3 and Q1 and Q3. So how many pair will be formed in the system of the charges? So first we will calculate n into n minus 1 by 2. It means total number of charges how much here? 3. Q1 minus Q2 and Q3. So 3 into 3 minus 1. So 3 into 3 minus 1 means 3 into 3 minus 1 by 2. So simply you can say here 3 into 2 by 2, it means 3. How many pair will be formed? 3. And for each pair, then we will use this formula U is equal to 1 upon 4 pi epsilon naught Q1 Q2 by R and calculate the potential energy. Like first we will calculate the potential energy U1 for first this pair Q1 and minus Q2 by using this formula. So this becomes U1 is equal to 1 upon 4 pi epsilon naught Q1 minus Q2 upon R1. Similarly, for these two charges minus Q2 and Q3, U2 is equal to 1 upon 4 pi epsilon naught Q3 into minus Q2 upon R2. And for third pair Q1 Q3, 1 upon 4 pi epsilon naught Q1 Q3 upon R3. And for finding the total potential energy of the system of charge, we will add their U1, U2 and U3 algebraically, or simply we will add the individual potential energy for each pair, and finally we calculate the potential energy of the system of charges. Now the next point, sixth point, is variation of electric potential energy with distance r. As you know, for like charges Q1 Q2 greater than 0, and when Q1 Q2 greater than 0, it means U becomes positive, and U becomes positive means repulsion will take place. And for unlike charges Q1 Q2 is less than 0, it means U becomes negative, and U becomes negative is attraction. So when you will draw a graph between U and R, means electric potential energy, and R, then for like charges means for Q1 Q2 greater than 0, it will show positive potential energy and it vary with the distance r as it is. And for if U is negative, then in this case Q1 Q2 is less than 0 and graph is indicated by this one here. So this negative value of U means attraction, positive value of U means repulsion, and its variation with the R is given by this graph. And last point, which is sixth point, is what here? The force of attraction or repulsion. For force of attraction or repulsion, the force of attraction or repulsion can be between the charges can be calculated by the formula F is equal to minus du upon dr. It means by using this formula we can find the force of attraction or repulsion between the charges if their electric potential energy is known. So all these are the important points which is included in this electric potential energy of the system of charges. Now next topic is equipotential surfaces. So as it is clear from its name here, equipotential means any place where the potential is remains same. So equipotential surfaces, you can define any surface over which the electric potential is same everywhere is called an equipotential surface. Like suppose Q is any point charge, and when we will draw a concentric spherical surface around it, then any point on this concentric spherical surface, the distance from plus Q is remain same. Like when we will take this spherical surface around this charge plus Q, So the distance of each point of this spherical surface from plus q is remains same. So you can say the potential due to this charge plus q at any point on this spherical surface B remains same. Similarly, the distance of any point of this second spherical surface from this charge plus q is also same. So electric potential due to this charge plus q at any point of this spherical surface be also same. But the potential on this first surface and potential on second surface is not same. Here the potential at each point of this surface is same. Similarly, the potential at each point of this surface is same. And the such type of the surface is called equipotential surface. So this one is the equipotential surface for this point charge plus q. Similarly, this one is also the example of equipotential surfaces. So simply you can say equipotential surface means any surface over which the electric potential is same everywhere. So what is the properties of the equipotential surfaces? So the first property of the equipotential surface is what here? No work is done in moving a charge between any 2 points on an equipotential surface. It means the work done in taking a charge from one point to other point on an equipotential surface be equal to 0. Why? You know the formula, the work done W is equal to Q into V, where V is potential difference. And when you will take any 2 point on the equipotential surface, so the potential at these 2 points is remain same. So V is equal to 0 or potential difference is equal to 0. So work done will be also 0. Second property is what? The electric field as well as electric line of forces be always perpendicular to the equipotential surface. It means either electric field you can say or electric line of forces be always at right angle or perpendicular to the equipotential surface. Third property, in a family of equipotential surfaces where the surfaces are very close, it means at that place the electric field is stronger, and where the equipotential surfaces are far, means at that place the electric field is weaker. And last point, two equipotential surfaces will never intersect to each other. Why? Because at the intersection point you can draw the two tangents, and these two tangents represent the two direction of the electric field, and at one point two direction of electric field is not possible. Due to this reason, two equipotential surfaces will never intersect to each other. So all these are the properties of the equipotential surfaces. So dear student, today you revise all these topics which I have discussed, and in the next video I will give the last topic of this exercise. Thank you.